This is an A-pillar bar, and anybody that's ever built roll cages knows pretty much every time, without fail, it's the single hardest tube to make. And today, we're gonna not make one, we're gonna make a bunch of them as we try to get it right, try to make it perfect. This is the most fabrication-filled episode on the F40 so far, but before we get started, if you've ever missed out on any of our merch drops, we've got a small restock of everything, and it's all 50% off while it lasts. StanceWorks.com/store, links in the description. Let's get started. In our last episode, we bent up the roll cage's main hoop for our custom F40 tube chassis. It is arguably the backbone, the most important piece of the entire structure. I spent a lot of time making sure that we got it to fit exactly the way that I want, with each of the bends and the outside dimensions perfectly in plane with the bodywork. It took a few tries to get correct, but the extra work is worth it, and we're going to be carrying that exact mentality forward as we build the A-pillar bars. With the A-pillar bars finished, it will be time to put the pedal down, and work is really going to pick up in speed. The rest of the tubes can start falling into place, but these A-pillars are not going to be an easy task. They feature multiple bends in different planes, and we don't even have A-pillars themselves in place in order to build them too. A-pillars are a part that I don't have from the original bodywork, so we need those, and we need the rain tray. And that brings us to this. This is obviously not a factory Ferrari piece, but it is a replica of one. This one was custom made by my friend Nathan Gardner. He's got an F40 replica project he's working on. I'm gonna put a link in the description so you can check it out. It's pretty cool. This is not a perfect copy, but it's close enough. We can use this as a rough draft while we wait on our OEM one to arrive, which I don't know when it's gonna get here. But what's more important than this piece is what's glued to the backside of it. We've got some custom A-pillar molds that Nathan made for us, and while they're based on Nathan's replica F40, meaning they are not perfectly accurate, they're going to be close enough. Now, as a quick reminder, the A-pillars on an original F40 are one of the only steel parts of the body. Given that we're not running the original chassis, we don't have those pillars, and they're not available from Ferrari, so making our own is required. Now, given these are based off of Nathan's replica, they are not perfect. But between these molds and taking molds off our 308, we're going to get close enough to perfection that no one will ever know otherwise. Now, obviously, these are molds. They are not A-pillars. So we're really kind of having to use them as a surrogate for the time being until we actually make some parts, which we're going to get done here in the next couple of weeks. Tim Hicks from Industry Garage is going to come over and help me make some, and that will get us at least somewhere. But in the meantime, we're just going to clamp these in place and kind of use them as a placeholder. It'll tell me where we need to build A-pillars. We can't really, build it as tight as we could for this tube work where it's touching the body the whole way down. That'd be nice to do, but beggars can't be choosers. So for the time being, we're just going to get this thing in place and use it as a temporary setup. It should be, what I would say, within the noise. It's close enough. I think we can get some A-pillars bent up that will fit with whatever we do bodywork-wise. I feel reasonably confident about it. And worst case, once we make these parts, if we got to redo some stuff, we got to redo some stuff. Let's give it a shot. But before we go actually bending up tube, there are still some variables I want to solve. One of them is finding out whether or not the roof skin is actually in the correct position. We've got an A-pillar mold holding it into place, so how do we know if the geometry is actually correct? Well, that's why we're back over at IM Detailing to take some measurements off of Nigel Mansell's former F40 once again. I took some measurements from the rocker panels up to different points of the roof skin itself, points that we can replicate on our car to make sure that everything is exactly as it should be. While we're here, I also spent some time measuring things in the door jamb itself. The location of these hinges are important, and you'll understand more here in a moment once I explain it, but remember how this door jamb looks. We're kind of going to replicate it, including what kind of space or room these parts take up in 3D space itself. I also want to know how far apart these pieces need to be in reality, so this F40 has come in handy more times than once. Thank you again, Jacob at IM Detailing. Now, back to the shop. Now, I've spent a number of hours this week designing this hot pink part here in Fusion 360, and if you're wondering what it is, I'm going to be honest, I've struggled to find the words to accurately explain what I'm trying to do here. But if my explanation doesn't make sense, if you just stick around, we're going to build this part and put it into the car, and hopefully then it will click. This is a template or a jig, and what its purpose is to locate the factory F40 door hinges in the correct place in 3D space. We've got to make sure that they are correct because the door hinges are one of the few things in this car that we get no say in where they go. They've got to be located where they were originally for the door to open and close correctly, for it to line up, and not have some sort of issue or to have to design custom hinges, and that's very difficult to do. I don't want to do it. This is going to make sure that what we build works correctly. But its secondary purpose, and probably more important in our case, is that it's going to provide some physical boundaries, some locations that we can then build to. We've got to build an A-pillar bar, and if we want it to come down the roof line, down the A-pillar, and then drop down to the chassis correctly, we need to know where these parts are going to be so that then, once we go to put these parts into the car, they can attach to the chassis properly. We're going to get this stuff built. Thankfully, I already sent everything out to SendCutSend. These parts are going to arrive here in about 30 seconds in your time. So let's put them together and then get them into the car. Now, hopefully you still remember what the inside of the door jamb of that F40 looks like, because that's essentially what we're replicating. Now, given that I want these jig pieces to be accurately located on our chassis table, especially since they lift up and off the surface, we're going to use a lot of clamps, squares, and more in order to get these things welded up without warpage. And that's a tough task. These won't ever be truly perfect, but we can get close enough. But to pull that off, I'm using every tool I've got. Our order of operations is going to be to build the upright tower for these jig pieces first. This seems like the easiest place to start, and it's one of the most critical. The other pieces that we're going to weld up for this project all kind of just fit together. They're hard to mess up, but this one has to be welded up straight or the whole thing's going to be incorrect when we're done. As you guys know, I love showcasing new tools, and I bought some new ones specifically for this project. And no, this is not a sponsored segment, but Jason over at Fireball Tool is an awesome guy, and I'm eager to support him, so here goes. He's got this incredible magnetic machined shim set, and it comes with all of the useful increments that you might need for a project like this one. If you guys keep an eye out, you're going to see me use them a number of times in this episode, to hold things at the correct distance apart, to keep them square, and to just make sure the project goes together easily. These things are accurate down to less than 1/1000th of an inch, and they're pretty affordable too. The entire set that I have here is $200. I'd say they paid for themselves in this episode alone, so if you're a fabricator too, I'd add them to your kit immediately. Now let's talk about these parts that came from SendCutSend. As you guys know, SendCutSend is one of my biggest partners here on the channel. But you also probably know, if you've been here for a while, that my partnership with them stems from organic roots. I began as a regular retail customer, and I loved their service enough that I had to take things a step further. I've said over and over again that their services are without question the most valuable tool in my toolbox, and I'm not saying that because I work with them at this point. I truly believe there's no chance that this F40 project would turn out the way that it's going to, or that the 308 would turn out the way that it has without this. You should absolutely boot up Fusion 360 and learn to use CAD, because you too can make awesome parts that are just like these, and it will completely transform your fabrication game. You don't have to sit here and hand make tabs anymore. You can make professional race-grade stuff just like this, whether you're building a tube chassis F40 or just working on a tiny project at home. So if you want to make some parts like mine, head to SendCutSend.com/StanceWorks and you can get 15% off, and you'll support this channel and this project at the same time. Now, it took a lot of clamps and squares to get these parts welded up and to not have them move around on me, but I think they came out really well. And one additional tip that I have is that I also had some spacers laser cut to correctly space these pieces apart so that I didn't have to worry about having anything slightly off. We can use CAD to build the car itself, to build tools for the car, and at this point, tools to build the tools. Now, I will admit, this is a lot of fabrication work just to make a tool as opposed to a part of the car, but my hope is that those of you that are really here and invested in this project are just as excited to see this stuff as the car itself. A lot of work went into these things, but they're an important piece to the puzzle, and they're going to help us make some important progress here in the next few weeks. Now, let's find out how they're actually going to fit up on the table. I think there's probably a few questions I can answer. So as we bring this into place, we know roughly where it should fit by just holding it where it should go. But of course, there are some questions about how do we make sure that it is exactly where it needs to be on the table. And that's why I 3D printed this. It looks like a jig that just lines up with the table because it is, but it has a slight offset to it that's going to help us make sure that this door hinge plate is exactly where it needs to be. And so if I take it, put it under the table, and then nest the corner of this thing into place, we can clamp it down, and I know that it's perfect. There's no room for error. It is exactly where it needs to be. And best of all, it means that it perfectly matches our CAD file. I can take any measurements off this and know that it is true one-to-one with what we see on the computer, and I can reference that to here or here to that, however we want to do it. So we know that these are in place, they're exactly where they need to be. We can also confirm by measuring to the chassis that everything else is right where it should be. It's shaping up really well. These are going to be really helpful in getting a lot of this stuff designed. Now back to the main hoop. A bunch of you guys asked in the comments of the last episode that if we cut the bottom of this thing so it sits flat on our base chassis here, isn't it going to then drop down and leave a gap for the roof and not fit awesome the way that I talked how I want the whole thing touching? Well, that's a good question, but there's one important thing to note, and that's that the roof right now is actually pushed up by this tube. It is not where it needs to be. There's a gap back here, and it's about an inch out of spec from the rocker panel up to the roof height. So by cutting this and dropping it into position, the roof will come down right where we need it to be. We can fit the A-pillars and really understand where those are going to be. And then last, to answer a couple of other questions, some of you guys pointed out that if this bend is right where I want it, then if we lower this, it's not going to be in the correct spot. And that's true, but it's unfortunately intentional because a couple of you noticed that the plane of this tube here is in the plane where the window is going to be. It wouldn't quite fit. It's a little proud right here. We can't kind of have our cake and eat it too. This bend does have to drop a tiny bit in order to be kind of in plane for the glass to clear, to have everything fit the way that it needs to so the car can go together. So we're going to cut the bottom of this tube, hope that it mounts up good, and see where we sit. Getting the main hoop trimmed correctly is going to be a process of trial and error. Of course, we can take some measurements, but we still have to put it back into the car and test fit it. We've got to make sure that the roofline drops to the correct position, and we're going to base that off the dimensions we took from the complete F40 earlier in the episode. Now, what's important here is I don't want to cut too much off. I want to make sure that the main hoop still retains contact with the top of the car, which brings up another question I've seen a lot of you guys ask. Don't I need to leave room for something like a headliner or interior trimming on this thing? And the answer is no. That's not quite the car that I'm aiming to build. The F40 LM never even had a headliner. It had some basic interior trimming, but a lot of the chassis and roll structure was exposed, and this car will be some imaginary version of an LM taken to the next level. This thing is going to read as race car inside, and if you're looking for comfort in this thing, well, you're gonna have to look elsewhere. We're not gonna find it here. I trimmed about an 1/8 inch off the bottom of the hoop for the second cut, and that brought it into alignment, more or less exactly where I want it to be. I was able to flex the roof itself right into position, and it keeps a little bit of tension on it, which I think is a good thing, but leaves a little bit of room for adjustment in case we need to fine-tune it in the future. With the roof line in the correct position, and with the door jamb supports we built earlier, we can more or less extrapolate the fact that our A-pillar molds are in the correct position, even if they're not perfectly accurate. As long as we leave a little bit of room for adjustment in the future, I think this is going to work out perfect. The main hoop trimmed correctly, I tacked it into place. It doesn't mean that this is final and won't ever come back out, but with any luck, I'm going to call this fully attached, and we will finish weld it later in the future. But as you guys probably know, I'm going to take everything to the furthest extent that I can, and I'm striving for perfection, or at least the closest version of it that I can get with these body panels. If you guys remember from the beginning of the build, we mocked the hood of the car up on a bunch of supports that I assume are at the correct height, but it's really hard to know whether or not they actually are. And so we turn back to our CAD data so that we can confirm that we have the hood in the correct place. This is important because the A-pillar location is partially based off of the hood. Now we have CAD data for the original F40 frame, which includes the pivot points for that original front clamshell. And so I've designed this yellow support here that will attach to our chassis table and can replicate that original hinge or pivot location. Now this isn't going to allow us to actually pivot the hood, but it's a good place to start. I sent these parts out to SendCutSend as well. They showed up a couple of days later, and now we get to assemble it. And this too is a careful exercise in making sure everything is square and true. I used tab and slot construction so that everything will slot together and be easy to assemble, and if you want to try something like this, my suggestion is to use 10/1000ths oversized holes so that everything will fit with some clearance. Now I will admit, I did make one rookie mistake as I put this jig together. I got all of the pieces assembled, tacked together, and mostly welded. And then I slid each end of this jig out to the ends of the crossbar. And then I tacked them into place according to my CAD drawing. Something like 44 1/8 of an inch between the inside plates or something like that. It doesn't matter. I tacked it into place and then just assumed that my bolted together chassis table would be so accurate that this jig would then bolt to the front of it with precisely sized holes with no room for adjustment. And how do you guys think that that worked out? Well, I'll be honest, I surprised myself. I walked to the front of the chassis table, held it up, and it fit absolutely perfect. No adjustment, no need to move anything. This thing bolted to the holes on the front of this thing like it was designed for it. And that means our chassis table is actually square, true, and flat. It's what it needs to be. It's a good sign. On the other hand, the dimensions of the mounts on the hood are not perfectly accurate in contrast to what they should be, but that's what you get from a handmade part. We can work with it. Now I made one other change over the weekend while Anthony wasn't here with the camera. I put a spacer behind this mount that supports the whole nose cone. I actually moved the entire thing towards me about a 1/2 inch, which surface level, I think that should be a pretty big problem. We're basing a lot of these dimensions off of our CAD data, and we know where the pivot points for this front clamshell should be with respect to the chassis table and where the rest of the chassis members are. But I've realized I can't take that CAD file as absolute truth. There's going to be variances between that file and a real chassis. There's probably variances between each chassis, and who knows how much adjustment Ferrari really gave these things when they were building them. How much did they mess with the chassis to get this stuff to work together? I don't know. What I have been told is that closing these clamshells is a lot of tension. There's a lot of flex that happens with them. And I'm trying to remove some of the tension that I'm finding where this thing closes. If you actually look at the gap here, now that I've spaced it forward, it actually lines up quite well. This whole line is really nice. It sits where it should be. I'm pretty happy. But where it was before, if we actually kind of like pull it back, it was more like this, and it required really flexing the hood in order to close it. The other side still has a little bit of flex to it, and I think I'm kind of just choosing a happy medium here, but ultimately, I think what I'm realizing is that we have to trust our eyeballs, and we have to trust the parts and the way they fit together. We gotta let the car tell us how it wants to be sometimes. We can't always say no, CAD data, hard measurements, etc. The chassis is still going to be perfectly straight. We're just going to add a little bit of that ½ inch of length to the front end, move that pivot point forward, the hood's going to fit better, and everything is going to line up the way that it should versus trying to force it. All right, so the main hoop is in position. It's tack welded. It's not going anywhere. The roof is where it should be. The A-pillar molds are clamped into place, and our door jigs are properly positioned, so we have kind of an outer boundary for the A-pillar bar itself. We are finally ready to start designing and bending some A-pillar tubes. Now, I showcased the entire process of how to measure this stuff in the last episode, so if you're curious what I'm doing here, you gotta go back and watch it. But otherwise, I'm gonna let this pan out and see where we land on tube number 1. Now, as mentioned at the beginning of the episode, A-pillar bars are typically the hardest ones of the entire project. That's because they feature a lot of different bends and planes that they have to line up with. Typically, they're going to have 3 bends minimum and sometimes 4. Depending on the car and the shape of the roof and the A-pillar, each of these bends could be on a different plane, and every time you add a new plane, that means rotating the tube before the next bend. It adds a lot of complexity. Every time you bend the tube, everything else kind of starts moving around, and these things can take a lot of work in order to get accurate. If you want an A-pillar to fit within a 1/16 of an inch across its entire length, and you're talking about 80 inches in this case, 1 degree of incorrect bend or 1 degree of incorrect twist can send the entire thing out of alignment, and that means you're wasting tube. That also means that 1 degree of miscalculation in any measurement, or even just a fraction of an inch, and you're gonna miss the mark. And that's why I'm gonna build our A-pillars out of DOM tubing instead of Docal R8 until we get all of our dimensions correct. It means we'll have to do it correctly a second time once we nail it, but I'd rather do that than throw a ton of Docal R8 in the trash. Now, a number of you guys asked on the last episode, how do I make sure when I'm bending one of these tubes that I keep it, for the main hoop, totally straight? And the honest answer is on something that is all in plane. Every bend is going to be in a line. I trust my eyeball above any gauge or anything else, and it doesn't lead me wrong. Your eyeball is really good at seeing level. So I put the main hoop in the tubing bender, I stand back from it, and I just make sure it's always lined up vertically and with the bender. You just make sure that it's equidistant, it works out. These hoops are flat. You can put a gauge on it if you want to. Now, on things like this, we've got bends that are in different planes. How are we gonna make sure that these bends are where we need them to be? Each one, we have to rotate the tube between each bend, and that is tough to get right. It's really hard. That brings me to measuring. There's a few different ways to do it. We could put the tube into the bender and just bend, put a gauge on it, and rotate it until it reads what we want. But I also like to give myself physical markers, and in this case, I'm gonna use millimeters. A bunch of you guys have been giving me a lot of flack for not using millimeters or the metric system on an Italian car. I gotta say, the tubing, it's measured in SAE. It's just what it is. It's 1.5 inch tube. The bender is measured in SAE because it's made here. The tubing protractor, the bend protractor, it's in SAE because it's meant for these things. It would be a big pain to convert all of this stuff to metric just because I prefer the metric system. We're just gonna use SAE where we need to, but for this, it's a lot easier for me to measure around the tube in millimeters than to try to do it in fractions of an inch. And in this case, we've got to do, it looks like, 13.95 millimeters. And on this tube, give or take, every 1/10 of a millimeter is a full degree of rotation. So it's really easy to wind off just by the width of the pen mark. So these marks themselves are just one reference that we're going to use. We could build the main hoop with them alone, but on top of that, I'm also going to use a digital angle gauge clamped to the tube after it's placed in the bender. This will allow us to make sure we rotate it the correct direction and the correct amount, and if it lines up with our marks and the indication on the bender itself, we know that we should be good to go. Now I gotta say, I think that tube number 1, test fit number 1 fits really well. We could take these dimensions and bend them up in our Docal R8 and call it done. It fits better than most A-pillars do. But if I'm gonna be really meticulous about it, there's room for improvement here. At the back, I think that this bend, realistically, we can move it forward a little bit and get a little bit more clearance out of the top. The tube right now touches perfectly all along the roof right here. It can't really get closer. And I gotta be careful not to tuck it up into the nook of the roof, or the roof won't be able to come off, which we don't want. But I think we can get a little bit more headroom in here and get the overall shape to look a little bit better, flow better with the line of the car. This position here, the tube is perfectly tucked into the corner of the roof. So this position of the tube can't change, it's perfect. But the location of the bend, I think, could move down the tube ever so slightly, and we could close this gap up right here, make it look really nice. The run of the tube looks really good. I might change things around a little bit. The big one being this bend right here should be further that way, so more section in this straight run of the tube, so that we have more clearance on the bend right here, and it will bring the bottom of the tube forward and give us that same 3/8 of an inch gap that we have at the back. Center it perfectly on our material. Overall, I really like it. There's one unknown, and that's because we're using the mold of this right now. We don't have the thickness of the material in place. I kind of have to like pretend that it's there. I can't tuck the tube in too tight or the part's not going to fit later. We don't want that. So I got to think some of it through. But as a whole, I think we're in a good place. This tube, this geometry, it would work. We could cut it, we could put it in, and I'd be happy with it. But I can be happier if we try it again. So let's try a second shot. Let's pull this out, run some fresh tape, take some new measurements, and try something slightly different and see which one works better, and then we'll go from there. If we're going to spend this much time building an F40, I want to make sure that it's as good as we can make it. But the downside is that for every 1 degree that we decide to rotate the tube or change a bend, it moves everything else significantly. For every 1 degree that we add to the first bend of the tube, it could move the other end of it by 6 inches or more. It makes making small changes a huge headache, so we're not just going to try this once. This is going to take a number of attempts to get perfect. Now, of course, we could just begin modifying the numbers that we have on paper, adding a little bit here or taking away some there to see if we can get the tube to go where we want it to go. But my approach instead of that is to start from scratch for each successive tube that we make. I think it makes more sense to get in there with fresh tape and fresh measurements, because moving the bend protractor itself just a tiny amount from where it was before could yield huge changes. I think that it's realistically a lot easier to take fresh measurements and to follow them than to try to modify the tube by adding degrees here or there and hoping you perfectly understand what it's going to do on the other end. Now, in total, I attempted this A-pillar bar 4 times. Now, each one was probably good enough to use if we wanted to settle. I can't make any huge complaints about how they lined up or how they fit, but again, I'm not in a rush to build this car, and I figure I'd rather look at it when I'm finished and know I didn't leave anything on the table, so we're gonna keep trying until we get it right. Well, looking at it, it's down right now because we haven't coped the end for the main hoop. So it's going to move up 1 tube thickness, 1.5 inches at the end, which will move it up, a bit here. It should nest it into this corner like we were aiming for. The rest of this should rotate, just kind of this way. If all goes according to plan, it'll kick a little bit like this. That'll bring that more vertical. Might have to throw an extra degree in, but there should still be room here for actual panel. It might actually be it. It might actually be it. It's a little bit further from the skin, roof skin here than I probably want, but it actually might go into position once it's there, so let's find out. That, of course, did not work, and thus came the 4th and final tube. Of course, it's important to keep very accurate notes of all the changes that I'm making because, again, we're going to have to build this tube a second time, and then we're also going to take all these dimensions and reverse them so we can build the opposite A-pillar. They need to be perfect mirror images of each other, and they need to fit side to side the exact same way, or I'm going to be unhappy. Well, I think this is it. It fits the way that I want it to, and I also think realistically it's going to be hard to make it fit any better without beginning to make sacrifices. If I want it to fit better to the roof, then the roof won't be able to come off. I want to make sure that it doesn't get trapped underneath this tube here, so I can't tuck it up further. I think that if I hug this higher up here, I'd get like a little bit more roof room or headroom, but I like the way that it looks and flows with the door opening. It's really nice and snug here. This flows perfectly. We've got a really nice even gap all the way down. Really, the only thing that this tube I think needs is just a little bit of extra length on it. I coped it a bit short there just as I was experimenting. I think these are our measurements. We'll leave a little bit of extra length that lands directly in the middle of that bend up on the main hoop, which is the strongest place to land it. That's where we want to reinforce the most. It'd be nice if it hugged kind of this part of the body down here, but I think as a cage structure, it wouldn't look as good. It wouldn't look as well built. This is where the tube should land. So that's where we're going to put it, right here in the middle of those bends. I think we got there. It took a lot of attempts, but we got there. Now we take this DOM tube and we bend it out of Docal, and we hope that all of the spring back that we're equating for, it will be different, but hopefully we can get it where we need it to be. We're gonna have to add a couple of degrees to every bend and hope that it doesn't all just start moving around on us and not fitting. So let's find out. With that said, I think this is a good stopping point. I want to get these A-pillars done, but what I don't want to do is waste and invest too much time trying to make perfect A-pillars when I don't have all of the pieces to the puzzle. Tim's going to help us knock out these A-pillars, and once these are in place, and I can truly fit the tube to it. Once I build this A-pillar out of Docal instead of DOM and it fits, then we'll flip it, we'll do the other side, and I'll know that we're done. And honestly, that'll be the toughest part of this entire fabrication project out of the way. Anybody who's built a roll cage knows that A-pillars are without question the hardest part of the entire thing, every time. Most of the rest of it will be straight or maybe have one bend. It's gonna be a lot easier. I'm excited. I think that this fits really nice. I think it turned out pretty well. It was worth the effort of making a bunch of them. I think you guys will agree. We've got all our dimensions. We'll account for the spring back. Hopefully on the next episode for the F40, we will have A-pillars made. We will mock them up into place. We will come back. We will make both of these A-pillar bars in Docal R8. We'll tack them into the car. And once those are in, we get to go pedal down on putting tubes in this thing. Progress is really going to start picking up. I'm excited for it. I'll catch you guys in the next one. And thank you as always for watching. I haven't said that in any of these episodes lately. We wouldn't get to do this project without you guys being here for these episodes. I am so appreciative of all of you that are watching, all of you that are subscribed, all of our Patreon supporters, all of our Discord members. You guys are awesome. Thank you so much for being a part of this. We'll see you in the next episode.